Welcome to the answer video of the question about the bottle of Coke. My name is Sharon and I will explain you how you could solve this question about Henry's law. In the right corner you see some given data about the Coke. You also got a table with some Henry constant for different molecules at different temperatures. In the first question, the bottle of Coke is closed, has a volume of 1.5 liters and is located in the fridge, so at a temperature of 5 degrees Celsius. The partial pressure of the carbon dioxide in the bottle is 3 bars. And we want to know the concentration of carbon dioxide in the bottle liquid. So the amount of carbon dioxide that is dissolved from the gas phase into the Coke. We need to use Henry's law to calculate the concentration. You learned in the theory about Henry's law, so we write Henry's equation down. We can find Henry's constant for carbon dioxide at 5 degrees Celsius in the given table. It is 9.16 times 10 to the power 7 Pascal, which is 916 bar. The unit is in terms of the pressure, just like the partial pressure. So the fraction of carbon dioxide does not have a unit. If we find the fraction of carbon dioxide in the liquid, we calculate the amount of moles of Coke in a bottle. We can do this by using the volume, the density and the molar mass. We will find an amount of 15.63 moles of Coke, which is 1 or 100% minus the fraction of carbon dioxide in the liquid. With this information, we can calculate the amount of moles of the carbon dioxide by dividing the amount of moles of Coke with 1 minus 0.0032 minus the amount of moles of Coke. This gives us 0.05 moles carbon dioxide. With the molar mass of carbon dioxide, which we can find in the given tables, we find a mass of dissolved carbon dioxide of 2.2 grams. So, the concentration is the mass divided by the volume, which is 2.2 grams divided by 1.5 liters, which leads to a concentration of 1.47 grams per liter. For the second question, the bottle is opened, so the pressure immediately decreases to 1 atmosphere, which is the pressure in the normal air. 1 atmosphere is about 1 bar. Also, the temperature increases to 25 degrees Celsius because the bottle is taken out of the fridge into the kitchen, of which the environmental temperature is 25 degrees Celsius. In a given table, we see that the volume fraction of carbon dioxide in the air of the atmosphere is 0.038%. So the partial pressure is 0.038% of 1 bar, which is 0.00038 bar. This is because volume percentages are the same as pressure percentages for air. The Henry's constant of carbon dioxide at 25 degrees Celsius we find in the table. Using this value, we will find a fraction of dissolved carbon dioxide of 2.22 times 10 to the power minus 7. The amount of Coke is still the same, so still 15.63 moles. Using this value and the fraction, just as we did in the previous question, we find an amount of moles of carbon dioxide of 3.5 micromoles. The mass of this amount of moles is 1.53 times 10 to the power minus 4 grams. So the concentration is 1.02 times 10 to the power minus 4 gram per liter. In this question, we see that if we increase the partial pressure, the amount of dissolved carbon dioxide increases if the Henry's law constant stays the same, of course. Furthermore, we see that if the temperature increases, the Henry's law constant of carbon dioxide increases, so the amount of dissolved carbon dioxide decreases if the partial pressure remains the same. Thank you for watching this video and good luck with the next chapter. If you still have questions, you can ask them via the forum.